Okay, here's a problem from the textbook. Bus starts from rest with a constant acceleration. Constant acceleration, so that means we're going to use the formulas that have been derived for us already. It doesn't say, but I'm assuming that this is going to be, because of the section it comes from, that the bus is moving in a single direction. So when you are looking for the distance or position or velocity or anything, you have to have an origin, you have to have a direction, you have to have a distance measure. So what I'm going to do is build those in by drawing a picture. So what we'll do is we'll say, all right, we'll draw a line. We'll say, okay, that's the road that the bus is traveling on.
Verizon Wireless.
Okay, and let me pause.
Verizon Wireless.
Okay, so this is the line represents the road that the bus is traveling on. I'll draw an arrow indicating the positive direction. I have to choose an origin, so we're going to choose an origin right here. Anything, if the bus is located here, it's at a position of 0. I'll draw a dot here. This is the bus. We're going to have a variable x, and if you give me the distance x, I will be able to tell where the bus is. They are telling me that the velocity starts from rest. That means his velocity is 0. There's no change in position. He starts with a velocity of 0 at a location of the origin. Okay, so now what I'm going to do is I'm going to I'm not sure why it disappeared, but there we go. So anyway, I want to count the degree of freedom. The degree of freedom is the number of motions that are occurring in the problem. I have a bus, and it is the only thing moving. The degree of freedom is 1. Doesn't mean anything to us yet, because we're doing, there's no decisions that have to be made as to whether this is chapter 12 or chapter 13 problem. And so it really means nothing, but there's only one thing moving, so there's 1 degree of freedom. Okay, so I'm looking for an equation that will take the things that I know, which in this particular case is the acceleration of 1, and relate it to what I'm looking for, which is time, for going a speed of 25. So I have the equations memorized. Hopefully you do too. One of them that comes out of the book is velocity is equal to initial velocity plus acceleration times time minus initial time, or original time, or whatever you want to call it. Okay, so what I'm going to be looking for is to see if this will work. They tell me that they wanted to attain a speed of 25. So the velocity I know is going to be 25. I'm assuming it's going to the right, and so that's why I put in a positive 25. And that equals the initial velocity. It says it starts from rest, and so the initial velocity is 0. Plus the acceleration is 1, so it's accelerating, I assume, to the right, so I'm going to put in a positive 1 here. I'm not adding 1, I just want to emphasize that it's a, I'm accelerating to the right. The time, I don't know the time when it hits 25. The initial time is going to be 0. I'm going to measure my my stopwatch. I'm going to click it when it's beginning at the origin there. And so if you look at this equation, the number of unknowns are 1. I don't know the value of t, and I have 1 equation. If you have 1 equation, you can solve for 1 unknown, 2 equations, 2 unknowns, etc. So I have good confidence that I can solve this, and obviously it's trivial. So you have 25 equals 1 times t is t. So how long does it take? It takes 25 seconds. So that's the that problem.